know about you, but I thought to be chameleon-like was to be someone who could fit in anywhere, adapt, blend in. Turns out that is all wrong. Chameleons don't change color to match their environment. In fact, it's just the opposite. Their baseline is camouflage. When chameleons are relaxed, they're mostly green. They naturally blend into their home in the forest canopy. They even mimic leaves by dancing around a little. But when they feel threatened or annoyed or just want to show a little swagger, that is when their color changes. They transform into living mood rings. Chameleons change color to make a statement. The faster their skin changes colors, the more excited they are. How do they do this? Well, it turns out we've been getting that wrong too. Until this year, scientists thought chameleons change color by spreading out pigments in their cells, like the skin of the squid we're seeing right here. But the truth is way more complex. Just below the surface of their skin is a layer of cells called iridophores. These cells contain tiny nanoscale salt crystals. They're only 130 nanometers across. That's less than 1/100th the width of a human hair. The crystals are arranged in a three-dimensional lattice. When light hits the lattice, it shatters into different wavelengths. Some are absorbed and some bounce back. The result, to our eyes, appears green or red or blue. The wings of the morpho butterfly have similar structures, which reflect brilliant blue hues. But unlike morpho butterflies, chameleons can stretch or contract the lattice, which moves the distance between crystals. Each of these points of light is an array of crystals. When the distance changes, the crystals reflect a different wavelength of light. The result is a dramatic shift in color. So what if we could come up with some kind of material that could change from one brilliant color to another? Electrical engineers at UC Berkeley are trying to do that, to mimic a chameleon's structural color control with synthetic materials. They arranged tiny nanoscale silicon ribbons on a sheet of flexible plastic. Each one of these pixels is made up of about 160 ribbons. When the plastic stretches, the space between the ribbons becomes greater, and a different wavelength of light is reflected, just like chameleon skin. Well, almost. This synthetic chameleon skin has just one layer of nanoscale arrays. The salt crystals in real chameleon skin are stacked in several layers, which makes their skin some of the most colorful and complex in the animal kingdom. They produce colors that aren't even visible to human eyes. What I like about chameleons is they show us how wrong we can be about science. What we called camouflage is an entire language, as alien to us as the clicks of a dolphin or the low rumble of an elephant. A visual language made of colors we can only begin to imitate and imagine.